9.2 Introduction. So in this video we're going to look at Taylor series, and actually for the next couple of videos we're going to look at Taylor series, but for this specific video we're going to look at how to determine a Taylor series from a polynomial. So the definition of a Taylor series is that a Taylor series is a polynomial that represents the behavior of another function near a specified point. So we can take a complex function like e to the x or ln of x, and we can write it as a polynomial, and then it becomes very easy to evaluate or approximate values. So the first thing I want you to do is try to construct a polynomial. P of x equals a naught plus a sub 1 times x plus a sub 2 x squared plus a sub 3 x to the fourth plus a sub 4 x to the fourth, such that these following conditions are true. P of 0 is 1, P prime of 0 is 2, P double prime of 0 is 3, the third derivative at 0 is 4, and the fourth derivative at 0 is 5. So I want you to go ahead and try to figure out what the polynomial should be. Alright, so I'm going to give you a little hint. For the first one, P of 0 equals 1. So I know my polynomial is going to be of the form. And so when I have this, P of 0 equals 1. So I'm going to go ahead and plug in 0. So when I plug in 0, I just get a naught, because everything with an x goes to 0. And I know P of 0 was equal to 1, so 1 has to be equal to a sub 0. It's got to be. Okay, so if I want to find the derivative, P prime of x, I just take the derivative. A naught goes away because it's a constant. And then the derivative of x is just 1, so it becomes a sub 1. Plus, I use the power rule, so I get 2 a sub 2x plus 3 a sub 3x squared plus 4 a sub 4 x cubed. Okay, so I want P prime of 0 to be equal to, and if I plug in 0, all of these terms are going to go away. So I just get a sub 1. And the problem told me that P prime of 0 equals 2. So then 2 is equal to a sub 1. So go ahead and now try to repeat this process to find out what a sub 2, a sub 3, and a sub 4 have to be. Okay, so let's try to find out what the second derivative will equal. And when you take the derivative of 2a sub 2 times x, you get 2a sub 2. Then use the power rule on the rest. 6a sub 3 times x plus 12a sub 4 x squared. So then I have P double prime of 0 is equal to 2a sub 2. And I know that P double prime of 0 is equal to 3. So I get 3 is equal to 2a sub 2. So then a sub 2 is equal to 3 over 2. We're going to repeat that process again. The third derivative, this term goes away, and we get 6a sub 3 plus 24a sub 4x. So the third derivative is equal to 6a sub 3 when I plug in 0. And I also know that the third derivative is equal to 4. So I get 4 is equal to 6a sub 3. So then a sub 3 is equal to 4 over 6 or 2 over 3. But I'm going to go ahead and leave it as 4 over 6 for now. Do that one more time. The fourth derivative is just equal to 24. So then the fourth derivative at 0 is 24. Oops, I forgot the a sub 4. So then we get 5 is equal to 24 a sub 4. So a sub 4 is 5 over 24. So now I've actually got all of the coefficients of my variables. I've got a naught, a sub 1, a sub 2, a sub 3, and a sub 4. So I'm going to go ahead now and rewrite my polynomial. So P of x is a naught plus a sub 1x plus a sub 2x squared plus a sub 3x cubed plus a sub 4 x to the fourth. And now we're just going to plug in the values that we got. A sub 0 was equal to 1. A sub 1 was equal to 2. A sub 2 was equal to 3 over 2. A sub 3 was equal to 4 over 6. And then a sub 4 was 5 over 24. And that's it. We did it. We wrote a polynomial where the first derivative is equal to 1, the second derivative is equal to 2, the third derivative is equal to 3, the fourth derivative is equal to 4, and the fifth derivative is equal to 5 when you plug in 0 for x. So there's some things we need to notice about this polynomial because it's kind of special. So first, I'm going to write something that might look a little strange. This is 1 over 0 factorial plus 2 over 1 factorial times x, 3 over 2 factorial times x squared, plus 4 over 3 factorial x cubed, plus 5 over 4 factorial x to the fourth. Now notice that the power of x here in the first one is 0. The power of the second one is 1, 2, 3, and 4. Also notice that the numerator increases by 1 every time. So a little review on factorials. 0 factorial is equal to 1. 1 factorial is also equal to 1. 2 factorial is 2 times 1, which is 2. 3 factorial is going to be 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24, and so on forever. That's just how factorials work. You multiply with all the numbers less than it until you get down to 1. So if I had, for example, n plus 2 factorial, this would be n plus 2 times n plus 1 times n minus 1 times n minus 2 times dot 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 times 3 times 2 times 1 until you run out of numbers. So let's look back at what we have here. We notice that each of the coefficients follows a certain pattern. So notice that each coefficient of the term of x sub n is equal to the nth derivative when you plug in 0 divided by n factorial. So looking back up at our equation, we have the second term is the first derivative over 1 factorial x to the first power. So if I want to find the x to the fourth term, it's going to be the fourth derivative when you plug in 0 over 4 factorial times x to the fourth. And that's exactly what we did.